All right, let's talk through this real quick. How did we find perimeter? Two of these and two of these added together, right? That's perimeter. How do we find area? Multiply these together, right? So we did that for each one of these. We found perimeter of this and area of this. Found perimeter of this and area of this. Perimeter of this and area of this. Perimeter of this, area of this. Yes? Then what did we do with the perimeters? They have to be up to 300, so we made sure that number was 300 or less, right? It had to be under 300, okay? And we went ahead and put check marks if it was under 300 and a sad face if it was not, okay? How did we do area? Greater than or equal to 2,600, right? So we did the same thing, check marks if it worked, frowny faces if it didn't. And then we said yes or no over here. And what made it a no? If it didn't fit the guidelines, right? This one worked, but this one didn't. It doesn't matter. They both have to work. So that one was a no, that one was a no, this one was a no. That left these two to be yeses, right? Now, can we think of all the possible dimensions that are up to 300 for perimeter and greater than 2,600 and then make a table like this and try all of them? We could. How long would that take us? Eternity, right? It would be an infinite amount of time because how many points are there in this? An infinite amount of points, right? So do you want to try that? Yeah, neither do I. Okay. I'm busy this afternoon. Okay. I already have plans. Okay. So what we need to do is we need to come up with a system that can express this for us so we don't have to do this. Okay. So let's look at, first of all, the first restriction. The rancher can afford up to 300 feet of fencing. What would that look like if we wrote that as an inequality? First of all, what does it deal with? What does the 300 feet of fencing deal with? Uh-huh. It deals with perimeter, right? So how did we find perimeter again? So I said 2 times x plus 2 times y, right? And that had to have something to do with 300. What did it have to do with 300? Less than or equal to 300. Very good. Now, we have to figure out what inequality we're going to graph it from, okay? Because we can't graph it from this, can we? What do we have to do to know what we're graphing from? We have to solve it for y, don't we? Okay, so if I subtract 2x from both sides, then I would have to divide everything by 2, right? What's that going to leave me? First of all, less than or equal to, right? 300 divided by 2 is 150 minus 2x divided by 2, so x, right? Any questions about that one? Okay. What about this one? What does this have to do with? Area. And how did we find area? So in this problem, it would be x times y, right? So x times y, and what did that have to do with 2,600? Very good, greater than or equal to 2,600. In order to figure out what we're graphing from, how do we solve this? Divide both sides by x, yes? Very good. So y is greater than or equal to 2,600 over x. Now the last restriction we didn't really look at up here. Okay, really didn't pay attention because they set it up for us that way, but there was one more restriction, and that restriction was let the x be the larger of the two dimensions. See how anytime there's dimensions, this one is the bigger one of these two? Okay, so how are we going to write that out? If x has to be larger, how are x and y related? X has to be larger, so just greater than? Just greater than? Why? Because it could be equal, right? They're allowed to be equal. So what form are we graphing from? Don't I need to like, So doesn't that mean y is greater than or less than? We don't just keep the sign, right? So less than or equal to x. Okay, so far? Now, what it says is use a calculator to help you sketch the graph of this system of inequalities, okay? What it does not want you to do is put these in an hit graph and kind of maybe possibly sketch what maybe might be on your calculator, right? We are going to use the calculator, okay? I'm going to start a new document that is a graph. But the way we're going to let our calculator help us with this is, first of all, we're going to go ahead and put these three equations in. I'm not going to try to graph the inequalities. If you'll give me just a second, I'll tell you why that's a terrible idea, okay? But I'm going to go ahead and put these equations in. 150x, sorry, minus x. And then 2600 over x. And then x. Okay? Now, I can't see anything. Well, I can see one thing on the graph, right? What's wrong with my calculator? My window. So menu, window. How am I going to know what to set my window at? Yeah, look at the graph that they give you, right? It goes from 0 to what? 150. I'm going to leave it at -10 because I want to be able to see the axis. But I'm going to go to 150 just like it asks. Oh no. Menu, window. I forgot to set my Y's. Tab, tab, tab. I'm going to let this be -10. And how far up do I need to go? Also 150, right? Now, like I said, I'm not using this to just like random haphazardly sketch this, but I did put it in the calculator for a reason, because now I can go Control T and I can look at the tables, can't I? Okay. And I'm going to know for the first equation, which I wrote in blue, so I'm going to graph it in blue. Okay. So we can keep them separated. It's this first column on the table, right? So 0 is 150. You can't see that. I'm going to zoom out just a little bit. I just want you to be able to see my calculator some. 0, 150. If I go down to 10, it's 140. If I go down to 20, it's 130. I'm starting to see a pattern. Are you? Can I go ahead and make the rest without looking at my table? Because that's a linear function, and linear functions we can see patterns pretty quick most of the time, right? Okay. Now once I draw this in, why am I drawing a solid line? Or equal to, right? Can we go ahead and talk about that right now? All of these lines are going to be solid, right? All of them are going to be solid. So I'm going to go ahead and just draw the solid line once I get the points there, yes? When it's time to shade, where am I going to shade on this? Below, right? I'm going to shade below because it is less than. Everybody okay with that? Okay. Now I'm going to graph the green line. The green line is what's next because it's the next column over on my calculator, right? Okay. But now I need to kind of, do you mind if I show you guys something that maybe make this a little easier? If we do menu and table, I want to choose to edit my table settings. And I actually want my table to start at 0. And I want my table to count by tens. Why do I want that? Yeah, on the graph it counts by tens, doesn't it? Okay. Now look at what my table looks like. That makes it a little bit easier, doesn't it? Okay. So let's see, I can't graph that point. I can graph that point, 20 and 130, right? That's right there. And I'm graphing this one in green because I wrote it in green over here. Okay. Let's see. 30. When x is 30, y is 86-ish. So maybe right there. 40 is 65. 50 is 52. 60 is 43. 70 is 37. 80 is 32.5. Maybe right there-ish. Now, am I getting this exact? I'm not, right? I'm not getting exact because I'm not a robot, right? But I'm getting as close as I can. Like I'm making my best guess, right? 90 is almost 29. Almost there. 100 is 26. 110 is 23. 120 is 21. 130 is 20. That's nice. And then 140 is 18. So it's just... And we already talked about the fact that this is solid, right? Okay. So how do I decide where to shade on this? Well, normally we would choose a point 0, 0, right? Because this doesn't go on 0, 0. But what happens if I try to put 0, 0 in right here? I'm dividing by 0, and that makes us very sad, right? But what if I go back to this equation and plug in 0, 0? Is that okay? Is 0 greater than or equal to 2600? No, it's not, is it? Okay, so wherever the 0 is, that's where I don't shade. So I shade on the other side of where the 0 was. Okay, so we've graphed two functions so far. And where's the only place that where the solution might be? Between the two so far, right? Okay, now I have one more function to graph. And I don't even think I'm going to use the calculator on this. I think I'm going to use my brain. Because I know y equals x, that's my parent function of a linear function, right? My intercept is at 0. And then my slope is 1. So I could rise 10 and run 10. Because 10 over 10 is 1, isn't it? So my last equation would be here, right? And once again, we already talked about the fact that it's a solid line. And now when it comes to shading, where would I shade? I don't have to choose a point this time, do I? Because it's linear, so I could just decide above or below based on the inequality sign, right? So what is it, above or below? Below because why? It's less than, right? So do you have a good idea of where we should shade now that we are all done graphing our functions? And where is that? So here. God bless you. All right, last thing it asks us to do is list several other possible pairs of dimensions other than the ones they gave us at the top. Okay, list other possible dimensions that would be included in this feasible region. What'd you say? 100 or comma, yeah, that's fine. 100, comma, 30. Does everybody agree that that point right there is in the feasible region? Why am I calling it the feasible region? What else could we call it? Yeah, the shaded area, right? This is just like more mathy math vocabulary, the feasible region. Okay, somebody else. 60, ooh, that's a tricky one, isn't it? Oh, it's not, is it? Why is it not a tricky one? It's on the line, and because it's a solid line, it works, doesn't it? Okay. Somebody else. Oh, 60-50. What do you guys think about 60-50? Okay. 70-50. You okay with 70-50? All right, let's see. Taryn, I can always count on you to be a little quirky. Can you give me one more point that's a little quirky compared to these? 75, so here. 43. So like right there, is that in the feasible region? Very good. You're allowed to just like the places where it intersects. I'm okay with that. I need you to make sure to know that all of these work too. What could we have done to be even quirkier? 75.5 and 43.1, right? So when it asks for list other possible pairs, how many do I want? 5, please. Okay.